Hello students and welcome to my YouTube channel 4stra. In this video we are going to solve AP Physics 1 free response questions that is being asked in 2025. So let's begin. This is question number 1 version J. A student has a card of mass mc and a block of mass 1 upon 5 mc. So this is mc. As shown in this figure, at time is equal to 0, the cart is moving to the right across a horizontal surface with a constant velocity vc, and the student release a block of from rest. At t is equal to t1, the block collides with and stick to the top of the cart. The block does not slide on the cart. At t is equal to t2, the block cart system continues to move to the right with constant velocity Vf as shown in this figure. So this is 1 upon 5 mc mass of block, and this is the card whose weight is mc. At t is equal to 0, at t is equal to 1, it sticks together, and after t is equal to t2, it moves with the velocity. So both moving with the velocity, common velocity Vf, and initial velocity was Vc. First question, A part, which says that on the axis shown below or in figure 2, sketch a graph of magnitude px of the x component of the momentum block cart system as a function of time from t is equal to 0 to t greater than t2. So the system considered here is block and cart. So our system is this block and the cart, including both this. So both are in system. So if we see the momentum at this point and the momentum at this final point, there is no external force. So we know that F external into time is equal to the change in the momentum. So there is no external force acting on the system. System is block and the cart, and there is no external force. So no external force acting on the system. So the Px, or I would say that P initial is equal to P final, since there this is 0. So I can say that the Px versus time, it would be a straight horizontal line showing that there is no change. It should be a straight line. So there is no change in the momentum with respect to time. Second part is saying drive an expression for the speed Vf, okay, of the block cart system after time t is equal to t2 in the terms of mc, vc and physical constant as appropriate. Begin your derivation by writing a fundamental physics principle or an equation from the reference information. So I am driving it here that F external into delta t is equal to change in momentum. And this F external, there is no force acting on the body, so it is 0. So I can write that the change in the momentum is 0, or the momentum is conserved. So I can write from the law of conservation of momentum, I can write P initial is equal to P final. So P initial means I am taking at t is equal to 0. This is my initial point, and this is my final point. So momentum is conserved. So momentum at that point when the only cart is moving and this block is having 0 velocity. So its velocity is 0 and it is moving with velocity Vc. So I can write initial momentum is equal to the final momentum. Final, the mass, the total mass of the system, the cart plus the block. So the block mass is 1 upon 5 mc, and the velocity which is it is moving, it is Vf. So when I solve it, it would be mc is equal to 6 mc upon 5 into Vf. So mc dot got cancelled from both the side, and Vf would be equal to 5 Vc upon 6. So this is the Vf, final velocity with which the system is moving. Drive an expression for the change in the kinetic energy. So this is not T but delta. In the block cart system from t is equal to 0 to t is equal to t2 in terms of mc, vc and physical constants as appropriate. Begin your derivation by writing fundamental physics principle of an equation or reference of an equation. Okay. So to drive, I am driving it here at this portion. So it is A, C, A third part. We have to find the change in the kinetic energy. Change is final kinetic energy minus initial kinetic energy. So it would be initial. So time final means at time t2 and initial means t is equal to 0. Get it? So at t is equal to 0, I can write that initial kinetic energy at t is equal to 0, only cart was moving, so it was half mc vc square, and final kinetic energy is equal to half mass of the system is mc plus 1 upon 5 mc, the block and the cart, and the now the system is moving with vf is equal to 5 upon 6 vc. So I just replace it here. So 5 upon 6 VC whole square of it, and it would be 6 upon 5 MC into 1 upon 2. And when you solve it, it would get cancelled, and it would be half MC VC square multiplied this whole term multiplied by 5 upon 6. So I can write that the change in the kinetic energy would be equal to final kinetic energy, which is half mc vc square into 5 by 6 minus half mc vc square. When you solve it, it would be half mc vc square 5 by 6 minus 1, and when you solve it, it would be minus 1 by 6 into half mc vc square. So it would be minus 1 upon 12 mc vc square. So this is the change in the kinetic energy. Now let's see the B point, which says consider the case when a new block is dropped and collide with the top of the cart. The new block slides along the cart during the collision but does not slide off the cart. Okay. The time interval from when the new block collide with the cart and moves together with the cart is delta t. Delta t, this is delta t, there is a frictional force acting between the new block and the cart. Okay, indicate the x component of the momentum of the new block system increases, decreases, or remains same during the delta t. So we have to justify the answer. Let's see. When this block is put on this cart, there is a friction, and due to that friction, this block moves some distance, but it does not fell off from the cart. So when the friction is there, it is must be some opposing force acting on this system, on this surface. There, if it is sliding in the opposite direction, so the friction is there in this direction as well as in this block also, at this point also, in block also there would be friction acting on the body. So it is basically internal forces. So there is no, this is not an external force, but it is internal forces. So these are internal forces. I can write that there is no change, it would remain constant, and because friction is an internal force, not the external one. So the change in the F external forces is 0 still in this case. So that's why there is no change in the momentum. Thank you for watching. Like the video, comment it, and subscribe my channel. If you want to learn from me, whether it's AP Physics 1, 2 or C, Mechanics part or E&M, you can connect me on this WhatsApp number, or you can email me on foster.physics@gmail.com. See you in the next video.